them to you. Okay, you just need to know how to apply them. These are called multiple angle identities. They are also sometimes referred to as the double angle identities. And if you look at what these identities are, we've got sine of 2x, cosine of 2x, tangent of 2x equals all these things, right? To double something means to multiply by 2, so that's where it gets its name. All right, so you are able to rewrite sine of 2x as 2 sine of x times cosine of x. You can rewrite cosine of 2x 3 different ways. As cosine squared of x minus sine squared of x, or 1 minus 2 sine squared of x, or 2 cosine squared minus 1. And you can write tangent of 2x as 2 tangent of x over 1 minus tangent squared of x. So all we're going to be doing today is taking these identities, replacing something in the equation with the formula, and then simplifying as much as we possibly can. Hopefully that gets us down to some answer, right, like a term. But if it's not something that's on our unit circle that we have memorized, we can only simplify as far as it will go, and you're not expected to have things like 12 pi 35ths memorized, right? So that would not be anything you take any further, all right? So number 1 says to solve and come up with all solutions for 2 cosine of x plus sine of 2x. All right, so the way this is written, 2 cosine of x is not anything that can be replaced. But sine of 2x is something that can be replaced, right? Sine of 2x, if you look up here, is that very first identity, right? So I'm going to have to keep the 2 cosine of x. Nothing I can change about that. But I can replace this sine of 2x with what they said sine of 2x was equivalent to, which is, right. And this is supposed to be set equal to 0, right? Okay. Now, just like when we've previously solved, usually one of the first things we try and do is factor, right? Do you guys see anything we could factor out? Cosine of x. Okay, so let's do that. So I'm going to factor a cosine of x out of both pieces. Then I'll be left with, right. Okay, so is there anything else I could factor out besides just the cosine? The 2. Okay, so let's actually factor out a 2. And then we're just left with 1 plus sine of x, right? Okay, and we don't have any exponents, so we can't really factor it any further. Now that I have my factors, what do I do to solve a factor? Right, so I'm going to set 2 cosine of x equal to 0. And I'm going to set 1 plus sine of x equal to 0. All right, so if I want to solve 2 cosine of x equal to 0, I need to divide by 2. But 0 divided by 2 is still just 0. Okay, so we are trying to think of where is cosine 0. Well, cosine is x over r, right? So I'm really looking for where x is 0, because r is never 0, right? So where does x equal 0? At pi halves and 3 pi halves, okay. It does say that we're looking for all solutions, not necessarily anything restricted. So maybe we say at pi halves plus or minus, how far is it from pi halves to that next one you guys said would be at 3 pi halves? So pi times some variable, whatever variable you want to use. N, we've seen z used. It doesn't really matter, whatever you like to use there. All right? Okay, so there is our solution for the first factor. Now we're going to do the same with that second factor. So how do I solve that second piece? Subtract 1. All right, so sine of x is equal to negative 1. Well, sine is y over r, right? R is always a positive 1, so we must be looking for where y is negative 1. Where is that at? 3 pi halves. Okay, so this would be x is equal to 3 pi halves. And nowhere else is that true, right? Only at 3 pi halves. So if I was saying that I'm looking at a continuous graph like we are here, it'd be plus or minus. How long would it take for me to get from 3 pi halves all the way back to 3 pi halves? Right, so plus or minus that 2 pi z. Okay. Now in this particular case, these kind of overlap, right? Because this one is eventually going to hit 3 pi halves, right? And it'll be continuous as well. So in this particular case, since they overlap, I could say therefore, that's what the 3 dots mean, is therefore, this equation right here actually works. X is equal to pi halves plus or minus pi z would represent all solutions for this equation. So that won't always happen, but it just so happens it did here. Okay. Okay, so let's take a look at number 2. Number 2 says rewrite using, yes?
In that case, would like both equations, if you just wrote both equations, they still count now? Like
Yeah, I mean, it's still the same thing. Just know if you were on a multiple choice question on the test, it might only have this piece because that encapsulates both, right? Okay, so it says write using a double angle identity formula from up above. This one, they did put us on a restricted domain, right? They said we're going from 0 to 2 pi. So I won't write it as plus or minus something, right? We'll just write it as a list of all the values where this is true. Okay, so right now we've got 4 cosine squared minus 2. That doesn't quite look like any of my identities from up above, but it's pretty close to one of them. Which one is it pretty close to? Right, this one right here, that 2 cosine squared minus 1. How could I make it look exactly like that? Exactly, so let's do that. So if I factor out a 2, I'll have 2 cosine squared of x minus 1 equals 0, right? Okay. So that means I could rewrite this piece right here as, what am I allowed to rewrite it as? Cosine of 2x, right? But in this particular case, it's not necessarily going to make it any harder to solve the way that it's currently written, right? So it doesn't matter if you do or don't notice the double identity here. If I were to just go ahead and set these two pieces equal to 0 as is, it's still going to have the same outcome. So if I were to just solve here, we know 2 does not equal 0, right? So that's not going to give me any solutions. I could solve this piece by adding the 1, right? So then after I add the 1, what would we do? Divide by 2. So we'd have cosine squared is equal to 1/2. How do we get rid of the square? Take the square root. All right. So remember, whenever we take the square root, we have to consider the plus and the minus, right? So that way we're not forgetting about any solutions. And remember, I can also write that as square root of 1 over square root of 2, right? What is the square root of 1? 1. Okay, so this is really plus or minus 1 over root 2, right? But we don't like a square root in the bottom. How do we rationalize the denominator? Multiply that. Square root of 2. So we do end up with plus or minus root 2 over 2. Okay, so plus or minus means we don't care if it's where cosine's positive or where it's negative. We want all the solutions, right? Okay, so for my answers, okay, if I do have my unit circle memorized, I already know where square root of 2 over 2 is for cosine. If I don't, remember cosine is number of fingers to the left over 2. So on my hand, which finger would I bend so that I've got 2 fingers to the left?
45.
Right, the 45 degrees. Okay, 45 degrees is what in radians? Pi fourths. Okay, so that would be my answer in quadrant 1, right? Pi fourths. But they said they want all the answers, right? Where cosine is positive and where it's negative. So that was quadrant 1. In quadrant 2, cosine is negative, but we still want the answer. What's a multiple of pi fourths in quadrant 2? 3 pi fourths. Good. All right, and then what about in quadrant 3? 5 pi fourths. And what about in quadrant 4?
7 pi 4.
Nice. Now, if they had only wanted where it was positive, we would only include the first and last. If they had only wanted where it was negative, we would only include the 2 in the middle. But they said they wanted all of them, so we got to list all 4. All right. Okay, number 3 says, given that cosine of theta is 5 over 13, and that 3 pi halves is less than theta, and theta is less than 2 pi, they want us to find all the following. All right, so if I'm between 3 pi halves and 2 pi, what quadrant am I in?
Quadrant 4.
Right. So when I draw my little triangle here, I am drawing a triangle in quadrant 4. So we had one of these on Friday as well. All right, so cosine, as we know, is x over r. So our x value must be 5, and our r must be 13. So this is one of our Pythagorean triples. So although they didn't give it to us, what do we know y is? 12. And we are in quadrant 4. What do I know about y values in quadrant 4? Negative. So that's actually a negative 12, right? Okay. And then they ask us to find sine of 2 theta, cosine of 2 theta, tangent of 2 theta, and sine of 4 theta. Okay, so I am allowed to rewrite sine of 2 theta as what from up above? Right. And now that we have our picture, we know what we're allowed to replace sine and cosine of theta with, right? So what would sine of theta be? Negative 12 over 13. So we're going to have 2 times negative 12 over 13 times, what is cosine? 5 over 13. All right, and then all we have to do is multiply, right? Simplify. You can put that 2 over 1 if it helps, but we're multiplying all of our numerators. So 2 times negative 12 times 5. What would that be? Negative 120, good. Over 1 times 13 is, what's 13 squared? 169. And there we go. All right. Okay, so one of the identities we haven't used yet is that first way to write cosine of 2x, right? We are apparently allowed to rewrite cosine of 2x or cosine of 2 theta as cosine squared of x minus sine squared of x, right? Or theta is what they used here. Okay, well, what is cosine? 5 over 13. All right, and this was squared, right? Because cosine is squared. Minus, what did we say sine was? Good. And this will also be squared. So we do know they'll become positives, right? What is 5 squared? 25. Over 13 squared, you guys told me was 169. Minus, what's 12 squared? Right, again, over that 169. So we do have a common denominator. All I have to do is subtract, right? So what is 25 minus 144? All right. Then they ask for tangent of 2 theta. Well, according to our formula from up above, we're allowed to rewrite tangent of 2 theta as 2 times tangent of x. What would tangent of x or tangent of theta be for us? Good. So 2 times negative 12 over 5 over 1 minus that same value, negative 12 over 5 squared, right? Okay. So in the numerator, I'm going to have 2 times negative 12 over 5, which would be good. And then in the denominator, I'm going to have 1 minus, what is negative 12 over 5 squared? Right. Okay, and if I want to actually subtract those, I have to turn that 1 into what? Right, so I'm going to trade that out so that it'll have that common denominator. So what is 25 minus 144?
119.
Right, we just had that. So we're left with 24 over 5 over negative 119 over 25, right? So now I've got a fraction and a fraction. What am I going to do? Right. Keep, change, flip. All right, so I'm going to have negative 24 over 5 times 25 over negative 119. So I could simplify a little bit, right? I could divide this 5 out, and if I take 5 out of 25, it would just become 5. All right, so now I need to multiply. So what's negative 24 times 5? We had that up here, right? 120, negative 120. Bless you.
Thank you.
Over negative 119, right? But 2 negatives do make a positive. So that's what we're left with. Okay. All right, so for this last one, I've got sine of 4 theta. So this is pretty close to what we had here, right? But it has a 4 instead of a 2. So that must mean that I multiplied it by 2. So whatever we get, we need to multiply it by 2, okay? So I'm going to go ahead and put me a 2 in front so I don't forget. And I'll write it as what we could be replacing it with, which would be sine of 2 theta, cosine of 2 theta, all right? So this 2 is only because of that 4. We just realized that means we need to double whatever we end up getting. All right, so we already found sine of 2 theta. What did we say that sine of 2 theta was? Right, so I'm going to replace this with negative 120 over 169. And we also already found cosine of 2 theta. What did we say that was?
Negative 119.
And then I just bring that 2 down in front, right? And then we just multiply that all together. So we're going to get some pretty big numbers this time. What is 2 times negative 120 times negative 119? Some of us got some calculators.
It's probably a big number.
It is a big number.
It's isn't it negative 240 and 48?
So if all I asked was to multiply the numbers that were numerators. What was that?
Yeah.
2 times negative 120 times negative 119.
Oh,
Okay. 28,560.
Right. Over, if I multiply those denominators, that'd be 169 times 169. What's 169 squared?
28,561.
Right. And of course, your allowed to put that in a calculator to simplify, but it's not going to, right? Because there's only one number difference there. So this would definitely be one you'd need a calculator for. Or it's going to take you a little while to multiply that out, one of the two. All right. Number 4 says to solve sine of 2x sine of x equals cosine of x on the interval from 0 to 2 pi. So this means a list of answers, right? Not plus or minus some value. All right, so right here, sine of 2x, that's one of our double angle identities, right? What am I allowed to rewrite sine of 2x as? Right. So I'll have 2 sine of x, cosine of x that I replace it with, times the sine of x from the equation equals cosine of x, right? Okay, anything we could multiply together or like terms to combine there? Right, sine times sine would be sine squared times cosine of x equals cosine of x. Okay, and if I were going to actually solve this equation, I need everything on one side if I'm going to factor, right? Okay, so I'd have 2 sine squared of x cosine of x, and I would move that over by subtracting, so minus cosine of x. All right, so what am I going to be able to factor out? Right. So pull a cosine of x to the front, and I'm left with 2 sine squared minus 1. All right, and now I've got my factors, and how do you solve factors? Set them equal to 0. So I'll have cosine of x equals 0, and 2 sine squared of x minus 1 equals 0. Okay, so when I ask you where cosine of x is equal to 0, we're thinking about where is x 0, right? Where at? Pi halves, okay. And 3 pi over 2. All right. Okay, so those seem to be our solutions from this part, right? Okay, so for that other one, we're going to have to do a little bit of solving. I'll have to move the 1 over, and then I'll have to divide the 2. So I'll have sine squared of x is equal to 1/2. And then what do we have to do? Take the square root. All right, and we said that the square root of 1 over 2 simplifies down to, right. And we just don't want to forget about that plus minus since we did take a square root. So plus or minus square root of 2 over 2. Nice. Okay, so since it's plus or minus, we're considering all quadrants, right? Okay, so where do we get root 2 over 2 for sine? 45 degrees or pi fourths, okay. So that's quadrant 1. What's it in quadrant 2? And quadrant 3? And quadrant 4. Nice. Okay. So these would be all of our solutions, since I did ask for a list. Also realize that typically, if this were like a multiple choice question, they would list those in order, like size order. So they may be rearranged just a little bit whenever you're checking for a multiple choice answer, okay? All right, on the back, we just got 2 left. Number 5 just says to rewrite using one of our double angle identities. Okay, so it looks pretty similar to one of our identities. But instead of a 1 and a 2, this has a 4 and an 8. What could we maybe do to fix that? Take out a 4. Let's do that. So if I take out a 4, I'd be left with 1 minus 2 sine squared, right? And according to the front, what are we allowed to rewrite or replace 1 minus 2 sine squared with? So this would be 4 times cosine of 2x. Do we have any idea what x is? So we can't simplify any further. That's it.
Wow. It scared me because there's so much space.
They just wouldn't fit on the front.
This next one's
Okay. So this one would be kind of like what we had to do on number 3, right? They gave us one ratio. They did tell us that it's found between pi halves and pi. So what quadrant are we in? Quadrant 2. Okay, so let's draw a picture of a triangle in quadrant 2. All right, and they told us that secant was negative 5 over 2. Okay, well, secant is the reciprocal of what? Cosine. Okay. So then cosine of u would have been 2 over negative 5, right? Okay. So that must mean our x value is 2, and our r value is, well, is r ever negative? So that must be what that's negative, the x value, which makes sense because in quadrant 2, the x's are negative. So we had to move that negative with the other value. All right, so this one is not going to be one of our Pythagorean triples, so we would have to do Pythagorean theorem to find the missing side, right? So I'd have negative 2 squared plus our missing side y squared equals 5 squared. So that'd be 4 plus y squared equals 25. So what's y squared? 21, and then we have to take the square root to find y. Okay, so this side is root 21. Okay, so when they ask for sine of 2u, how are we allowed to rewrite sine of 2 times a variable? So 2 sine of u, cosine of u. All right, and this figure is representing u. What would sine be in this figure? Good. And what is cosine for this figure? Nice. All right, so remember, treat your radical like a variable. So this is basically like 2 times, this is treated like an x, times negative 2. Well, 2 times negative 2 would be negative 4. And then we just treat that radical like a variable. So we just tag it on, just like negative 4x, right? Over in the bottom, I've got 5 times 5, which would just be 25. I can't simplify square root of 21. Nothing multiplies to give me 21 and has a square root, so that would be it. All right? You guys do cosine of 2u and tangent of 2u, and then we'll share our answers.
Yeah, like the fraction.
It drops the square root. What do you mean? If you square something that's in a square root, It just cancels out the square root. Whatever.
Thank you. Mm-hmm. Uh-huh.
What'd you get?
Is tangent x over?
It's y over.
Y over x? Okay, that's what I thought. That's cool too. I really should calculate.
How would we know? Does it matter which one we
Nope, you can pick any of them.
Yeah, but I just.
Like, this is what I was kind of lost on the notes. I didn't get like how we got to 120. Because I saw that you were 120.
I think you have some things wrong.
2 times root 21.
So this is over 5.
Oh, 5? Oh, not 20.
And then that would still be 5.
That wouldn't be right.
Okay. So let's see. Cosine of 2u. We actually have 3 options for how we're allowed to rewrite cosine of 2 times some variable, right? It does not matter which one you pick. So I know a couple of you asked me, how do you know which one? It doesn't matter. Whatever you want to rewrite it as from that list of 3 choices. So you could use cosine squared minus sine squared like we did on the front. Or maybe you want to use the 1 minus 2 sine squared or the 2 cosine squared minus 1. It doesn't matter. So maybe we change it up this time. I'm going to use the 1 minus 2 sine squared. Okay? What is sine in this figure? What is sine in this picture? So this would be 1 minus 2 times root 21 over that hypotenuse 5 squared. Okay? You can use any of those 3 formulas from the front page. It does not matter which one you use. And we all are still going to get the same outcome. Okay? What do we end up getting? Even if you used a different way to get there than I did, what'd you end up with? Right. So it does not matter which one of those 3 identities you use. We're all going to get the same thing. All right? Okay, then for that last one, tangent of 2u. So this one would be 2 times tangent. What is tangent in this figure?
Root 21 over 92.
Good. All over, we'd have 1 minus that same value squared. Okay, so in the numerator, we would get 2 root 21 over negative 2, right? And that positive 2 and negative 2 cancel, right? So I'm just really left with negative root 21, right? In the denominator, what is root 21 squared? 21. And what's negative 2 squared? 4. So I would change that 1 to 4 over 4, right? And what is 4 minus 21? Okay, so we're left with negative 17 over 4, right? Okay, so I still have a fraction within a fraction, so I keep that first part. So I'm going to keep my negative root 21, change to multiplication, and then I'm going to flip my fraction over. So negative root 21 times 4 would just be negative 4 root 21, right? Over negative 17. So that won't necessarily simplify, but two negatives do make a positive. So we're left with 4 root 21 over 17. All right.